Let's do a little review of what we did yesterday. So what if I told you to simplify this right there? Hopefully you should just be able to do that in your head if you think about it for a couple seconds. If you want to write it down, you can. Come up with an answer for that. Square root of 45. Simplify is what it would say. Simplify. Alright, Leslie, what do you get?
3 square root of 5.
Very good. Let's see how she got 3 squared of 5. Right? She took 45. You could break it all the way down into its prime numbers if you wanted to, okay? But you don't have to on this one. This one's kind of an easy one where you can just kind of do this in your head. I think what times what is 45? Well, there's a couple things that multiply together to become 45. But what's the one that I really want to use, though? What times what is 9 times 5. Now, why did I pick 9 times 5? I could have picked like 3 times 15, right? That's 45, isn't it? Why didn't I pick 3 times 15? Why did I pick 9 times 5? Because 9's perfect square. Very good. I can take the square root of 9 and come out to a nice whole number. So that's what I want to try to think of. So when I have these things, I want to think of what times itself is equal, or if I multiply them together, which one's going to be perfect square. I like how you said that. A perfect square. So it's 9 times 5. Now remember the rule that we have for square roots. If I have two things being multiplied inside that big square root, I can split them up into their individual square roots. So I could make this the square root of 9 times the square root of 5. Now, most of this, if not all of it, can be done in your head on the particular one. Some of the ones you're going to have to write out. Right? But this one you should be able to think of in your head. And then what is the square root of 9? It comes out to a 3. Right? Not a square root of 3. And I've said this a lot. I said this yesterday. And I know, just because of the past, that somebody will put the square root of 3. It's not the square root of 3. It's just the number 3. Just the whole number 3. So it's 3. Square root of 5, I can't do anything else with it. So I just keep it the square root of 5. So it's 3 square root of 5. Just like that. Okay? Let's do another type. Let me find okay, let's do this one. What if I said, now if I just said the square root of 81, that'd be easy. What's that?
9.
It's 9, right. But what if I did this? The cube root of 81. That's not quite so easy. So let's do this. Remember how we take that thing, we break it down into its prime numbers? Let's go ahead and do that. Let's take 81 and break it down into its prime numbers. If you want to use that factor tree, you can. On this number, you might just be able to do this in your head, but I'm going to show you how to do this. So give me anything times anything equals 81. What? 9 times 9. Yeah. Now take 9 and break 9 down. What's that going to be? 3 times 3, and then 3 times 3. Everybody see that? So now I've broken it down into its prime numbers. Those are the smallest numbers that multiply together to become 81. Does that make sense? Those are prime numbers. So I could do this. I could go 3 times 3 times 3 times 3. Would you agree that that's 81? Now watch this. This is a little bit of a trick here. It's not really a trick. It's just really going by what the cube root means. What does the cube root mean? The cube root means what number times itself how many? 3 times. So watch what I'm going to do. Since I have a cube root right here, I'm not going to pair them up like I did when it was a square root. What do you think I'm going to do? I'm going to group them into groups of 3. That's right. You see that? Okay, because it's the cube root. Oh, I almost forgot the cube root right there. So it's the cube root. Lots of 3's going on here. But it's the cube root of 81. So if it's the cube root, I want to find out what number times itself 3 times is going to be, is going to come out even. So I group 3 of them together. Now, what's that going to be? What is the cube root of 3 times 3 times 3?
3.
It's just 3, exactly right. So the cube root of this right here just becomes a 3. A whole number 3. Not a square root of 3, not a cube root of 3. Just a whole number 3. Because 3 times 3 is 9 times 3 is 27. What's the cube root of 27? It's 3. All right? So if I have a group, every time I have a group of 3, if I'm doing the cube root, it's just that number. Now, I got rid of those from my radical, from that cube root, right? It became a whole number out here. What do I have left over?
Cube root of 3.
That's it. It's the cube root of 3.
Emphasis on cube.
That's right, because a lot of people will put square root. I almost forgot myself to put that as a cube root. Okay, a lot of people will write square root of 3. I've seen that many, many times. But you got to remember, you're taking the cube root of it. So it's 3 times the cube root of 3. That's the same thing as the cube root of 81. Let's do another one. Let's do a cube root again. Okay. That one's too easy. Let's find a better one. Okay, here we go. Cube root of 250. So if you're not sure where to start, take that 250 and let's break it down into its prime numbers. It really doesn't take that long. I mean, you think, oh, 250, that's too big, it's going to take forever. It really doesn't. It ends in a 0, so here's a little trick for you. If it ends in a 0, 10 goes into it, doesn't it? All right, so let's write it as 25 times 10.
I wrote it as 125 times 2.
You can do that as well. Let's just do it like this. And you're right, you could do 125 and you could figure out what the cube root of 125 is, but not everybody sees that. Let's do it like this. So what's 25? Well, it's 5 times 5. Break down 10, what is that? Well, it's 5 times 2, isn't it? Everybody see that? So that's what I did with 250. So now I'm going to put it, don't forget the cube there, I'm going to put it all under here. So I've got 5 times 5 times 5 times 2. Now it's the cube root. So how are we going to group these? Are we grouping them in pairs? No, we only group them in pairs if it was the square root. Okay, this is not a square root, this is a cube root. So I'm going to take the numbers that are the same, and if I have 3 of them, I'm going to group them in groups of 3. So I like to circle it just to see what's going on. So it's kind of like this, isn't it? So what is the cube root of 5 times 5 times 5? It's just the number 5. That's right. So the cube root of 5 cubed, basically, isn't it? Right? 5 times 5 times 5 is 5 cubed. The cube root of 5 cubed is just 5. All right, so I break them down. If I see a group of 3, I circle it, and if it's the cube root, it's just whatever that number is. All right, the cube root of 5 times 5 times 5 is just 5. All right, so I'm done with that. I took that out of the cube root. What am I left with now? A 2. But it's not the square root of 2. What is it? It's the cube root. It's supposed to be a 3 right there. Let's try and make it look like one. There we go. So it's 5 times the cube root of 2. That number right there is the same thing as the cube root of 250. It's not too hard, is it? Break it down to its primes, group them together in groups of 3. And why groups of 3? Because we're taking which root?
Cube.
The cubed root, the third root. So we break them into groups of 3. What if it was a square root? What would we break them into?
2.
Groups of 2's. Right. What if it was the fourth root? What would we break them into?
4.
Groups of 4. Now this one, you can't take the fourth root, can you? Because there's not 4 of the same number, are there? So you can't do that. What if I did this? Let's stick with cubed for right now. Let's do one that maybe is not quite as familiar. Might need a calculator on this one. All right, the cube root of 343. Tell you what, let me get a calculator. All right, let's take a look at this. Got a calculator. Oops, that's not a calculator. Wrong one, this one. There's a calculator. So what do I want to do? I want to take that 343 and I want to break it down into its primes. Let's see what we can do. Now, I really don't even know what goes into it. 2 doesn't go into it, does it?
I think
All right.
7 goes into
All right, let's try that. Well, let's look at some other numbers first. Does 2 go into it? No, because it's not even, okay? So you know 2. 5 doesn't go into it. 10 doesn't go into it. Let's try 3. Do you know the trick for 3?
No.
To see if 3 goes into it?
Doesn't.
Right, well, what's the trick? You add the digits up, right? So let's add them up. 3 and 4 is 7, and 3 is 10. So if you add the digits together, 10. Does 3 divide into 10? No. So 3 doesn't go into 343. Do you remember that?
Not 3.
Okay. So let's try another number. Let's try, now 6 wouldn't, right? Because 2 goes into 6 and 2 doesn't go into this. And so let's try 7. Let's try it. 3, oops, turn it on. 343 divided by 7. Oh, look at that. Comes out nice to 49. So 7.
I was right.
Yes, you were. 7 times 49. All right.
7 cubed.
Break that down, and 49 is 7 times 7. Now look at this. This is not a number that I'm very familiar with, but the rule still works, doesn't it? Alright, it's the cube root. Now watch, look what I have. I got 7 times 7 times 7, and it's the cube root. So what is the cube root of 7 times 7 times 7?
7.
It's just 7, and that's it. Okay?
I told you
So
it
that
was
one
different.
came out nice and even, didn't it? It doesn't always come out like that, but that one happened to. And if you're not sure about it, what can you do? Break them down to its primes, put them in here, and then do our little thing with the prime numbers. Yeah, you got to have cubed. It's not cubed. It's just the 7. Okay, because the question is, when it says the cube root of this, what number times itself 3 times is equal to 343? Well, 7 is, right? If I take 7 and multiply it by itself 3 times, right, I'm going to get 343. So the number is 7. It's not 7 cubed. It's just 7, right? It's like this. The cube root of 5 times 5 times 5 is just a 5, right? And up here we did it again. The cube root of 3 times 3 times 3 is just 3. It's not 3 cubed. It's not the cube root of 3. It's just the number 3. Okay? So that's a part that a lot of people kind of mess up on a little bit. Let's do another kind. I mean, same type of deal, but trying to find. Oh, here's a good one. Look at this one. Fifth root of 3,125. Look at that. Let's give that one a shot. Now, we're going to break it down into its primes. That's the first thing we're going to do, because 3125, I don't recognize that. Do you? As some kind of special number? I don't know off the top of my head what the fifth root of that is.
5.
Okay, so let's just figure out what goes into 3125. Well, it ends in a 5, right? So
Ends in a
obviously
25.
it does end in a 25, right?
So that means 25 goes into it.
Okay, let's just do the 5 for right now, because not everybody knows that. Okay, so watch. Let's go 5. So 5 goes into 3125. I want to make it as simple as I possibly can so people aren't getting confused. Okay? Right here. So 3125. 3125. And let's divide that by 5. Let's see what we get. We get 625. Now, I actually do recognize 625. You may not, but let's take 625 and break that down some more. Ends in a 5, so guess what?
125.
Divide that by 5 again, and you get 125. So I've got 5 times 125, right? Let's keep going. There's the 5. There's that 5. What about 125? Can you do this in your head at this
5
point?
times 25.
It's 5 times 5 times 5, isn't it? Is 125. Okay, because 25 times 5 is 125, isn't it? We went over that number yesterday. So it's 5, 5, 5. So this actually comes out kind of nice.
I told you it.
I know you did, but it's not just a matter of knowing that you got it right. It's a matter of understanding how we got it. Okay. Now you could have just stuck it into a calculator and done the fifth root of 3125, but I'm trying to show you more than that. I'm trying to show you more than just getting the answer. Okay, I want to show you where it comes from, because they're not all going to come out nice and pretty like this where you can just stick it into a calculator and get some nice even answer. Alright, sometimes they're going to be a little uglier. So it's the fifth root. So what am I trying to group them? I'm trying to group them in groups of 5s, right? A lot of 5s running around here, right? So what is the fifth root of 5 times 5 times 5 times 5? It's just plain old 5, isn't it? It's not 5 to the 5th. It's not 5 cubed. It's not the square root of 5. It's not the fifth root of 5. It's just the number 5. And that's it right there. What if I gave you this? What if I gave you, let's go back to square root, okay? Let's do the square root, and watch this. What if I did x squared, y to the 4th, z to the 6th? Look at that. What do you think? Well, let's do this. It's a square root, right? So we want to group them into what? Into 3s, 4s, what?
twos.
Into twos, right? We're going to group them into twos. Let's see if we can group these into twos. So x is already grouped, or x squared is already grouped into 2, isn't it? All right, so what would the square root of x squared be?
X.
Just be an x, wouldn't it? Okay. Now, what about y to the 4th?
2y squared.
That's right. I could put y squared, couldn't I? Do you see that? So look, I've grouped them, or you could put 4 y's there if you wanted to, couldn't you? Y, y, y,
Well,
y.
equal the same thing.
It'd be the same thing, okay? But it just depends on how you want to look at it.
That just requires less writing.
Exactly right. What about this one, z to the 6th? How could I split that up into pairs? Z to the what? You could go z squared, but it'd be z squared, yeah, you could do it that way if you wanted to. Let's do it like this. Because I just want to split them up into pairs. Make that look like a 3. Does that make sense? So watch. What am I trying to do? This is a pair, isn't it? So what's the square root of x squared? It's just what? Just x. I paired these together, didn't I? Alright, so what's that going to be?
Y squared.
It's going to be y squared. I paired these together. What's the square root of z cubed times z cubed? It's just what? It's just z cubed. Is there anything left after I got rid of this, this, and this? Nope. There's not. And that's how you do it. You could do it another way. I mean, you could write it all out real crazy. I mean, you could go x, x, and then y, 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 and then 6 z's, right? You could do that and then pair them all up if you wanted to, right? But that would be a little bit too much. That'd be a little bit too much, don't you think?
And I have a feeling that if I tried writing 6 z's out on a piece of paper, I'd fall asleep.
You fall asleep. Well, I don't think 6 of them is that many to fall asleep, but you know, you might miss one though, right? If you start getting 5 or 6, you might miscount or something like that. All right, so here we go.
To those old cartoons where they show someone snoring.
Gotcha.
And all the Z's.
Oh, the Z's. I gotcha. Like, what do they call them?
Catching.
Sawing, catching Z's? Is that what they say? Catching Z's, right? All right, look at this one. Let's try this one. 24, m to the 6th, n to the 5th. Right, I didn't... we don't need this quite as long. Just shorten it up. All right, look at this one. This one's a little different. So what do you think we're going to do? Let's take 24 and let's break that down. You could do that whole prime number thing if you wanted to. But there's a nice number that I can pick. What would you pick? 6 and 4. That's what I would pick too. I'm going to put 4 first. Is that all right? So 24 is 4 times 6. You know what we're going to do with this, don't you? What's the square root of 4? It's just a 2. And then the square root of 6 is left over, isn't it? What about the m to the 6? How could I rewrite that? Yeah, I could write m to the 3rd, m to the 3rd, couldn't I?
Yeah.
All right, that way I'm pairing them up. Remember, I'm trying to pair them up. And so what am I going to get when I take the square root of this? Just m to the 3rd, right? What about n to the 5th, though? Now, that's a little different. Why is that a little different from what we've done? Because it's odd. That's right. It's a little different. Okay, so let's break it down, though, into pairs. There's 5 of them, right? We don't have to write all 5 of them. What would be a nice way to write them? Maybe n squared. How about another n squared? That's 4 of them. And then we need how many more? Just 1 more. Everybody see that? So even though it comes out odd, that's fine. I write it n squared, and then I've got an n left over. So now, what do we do with all this stuff? That's the hardest part right there. Once you get that part, the rest of it's actually kind of easy. So let's take them up. Let's simplify them a little bit. What's the square root of 4? It's just a 2. It's a whole number 2, right? It's outside of the square root now. So I like to mark it off so I know it's going outside the square root. The square root of 6. Can I do anything with the square root of 6? Can I simplify that? No. 3 times 2, there's no way I can. So it's going to stay inside the square root. We'll just hang on for a second. What about this? Remember, I'm pairing them up. What's the square root of m cubed times m cubed? It's just m cubed. Good. So that goes outside the square root. You see why I wanted to pair them up like that? What about the n's? Well, I got an n squared here and an n squared here. I could pair those two up, right? They're the same thing. So what's the square root of n squared times n squared? It's just n squared. Because it's whatever that number is, right? So this was an m cubed, so we brought out an m cubed. Whatever number this is, is an n squared, so I bring out an n squared. Okay? Now, see all the stuff I marked off? They're all the stuff that goes outside the square root. What's left inside the square root now? A 6 and an n. And that's your answer right there. It's kind of weird, but that thing is the same exact thing. We simplified it, okay? We just simplified it. It represents the same thing, but it's just a simpler way, I guess, to write it. Some people look at this and say, oh, that was just as easy. Everything's all just compact inside one square root. But this is what they consider to be simplified, because you can simplify the square root of 24. You can simplify this and this. Bring the stuff out front, and then this is what's left in your square root. Think you can do this stuff?
Yeah.
Okay, it's not too bad, is it? All right, let's see what else I got for you. Let's go another rule. Remember this rule? Remember this rule right here, where I have the square root of x times y? What did I say you can do? You could go the square root of x times the square root of y. So you can take these and break them down into two square roots. What if I had something like this? How do you think you could rewrite that? Look, if these were multiplied, you just multiply them together, put them under their own square root, don't you? What about this right here? What do you think you might do? This is all under, this fraction, this division is under one square root. Come on, take a wild guess. It's not that hard. You can see. Look, if you're multiplying together, you just put each one under a square root and multiply them. This is one big division problem, so how do you think we can simplify that? What's that? Do the same thing, but it's not multiplied, it's what? It's divide. So tell me, Destiny. No reciprocals. Exactly. It's the square root of x divided by the square root of y. Good. All right. Does that make sense? If this rule is the way it is, then this rule is going to be the same thing. All right. So that's pretty important. So for instance, if I had the, let me just pick a, what if I had this? What if I had the square root of 16 over 9? And I asked you to simplify that. Now, can you actually simplify 16 over 9? Does anything go into 16 and 9? Yes. No. So what can you do, though? It's under a square root, so I can use this rule right here. Call this the quotient rule for radicals. Well, it's not the square root of 4. Yeah, but let's do the in-between step. It's the square root of what? Not the square root of 4. It's the square root of 16 over the square root of 9. See that? All I did, really simple, I just put a square root for the 16, a square root with the 9. All right, we're good to go. Now you can do this. Now, Leslie, I mean, I understand why you said 4, but it wasn't the square root of 4. It's what? It's just plain old 4, right? Because the square root of 16 is 4, and the square root of 9 is 3. So that reduces to just 4/3. You okay with that? Questions on that one? That's not too hard, is it? No? Let's do another one. What if we had this? All right, look at that one. It's a little crazier, isn't it? It's the same rules, though. Same rules apply. So let's split them up. So on the top, you just have the square root of x to the 5th y cubed, and on the bottom, you have the square root of z squared. And now we apply that other rule that we were doing before. All right, let's split them up so that they're pairs. All right, because we're taking the square root, right? So I want pairs here. So x to the 5th, how can I write that? Well, x squared, and an x. That's 5 of them, isn't it? All right, what about y cubed? Yep, y squared and a y. Everybody see that? On the bottom. Now look, this is all ready to go, isn't it? What's the square root of z squared? It's just z. It's not z squared. It's just a z. Right? Because remember, this is the same as z times z, isn't it? We pair them up like this. There's two z's, right? So it's just z. What about the top, though? Let's simplify that. What about this? What's the square root? Well, you could do it you could look at it a couple ways. We've been looking at it like this. What's the square root of x squared times x squared? It's x squared, isn't it? Okay. And then you have an x left in here, don't you? I'm going to cross it out. Don't forget about that. What about this? The square root of y squared.
Y.
It's just a y. Good. So let's see what's left over inside of here. So I got rid of that. Just have an x and a y left inside the square root. So x and y go in here. What's left on the bottom? Just a z. Not a square root of z, just a z. And that's your answer. That's how you would simplify this thing right here. Alright? Just applying the same rules, right? We're just doing division, just do the stuff on the top and on the bottom. It's really not much different. So the division really isn't that big of a deal. It's just knowing how to simplify the stuff inside of there. Alright? Let's see what else we can do. What if you had... Let me find a good one here. Okay, let's do this one. This is a good one. Let's go blue. Writing these down. Let's do the cube root. We have a 16. We have z to the 5th. We have x to the 8th. And y to the 4th. But it's cube root this time. It's not square root. So we're not going to split them up into pairs. We're going to split them up into groups of what? 3. So let's do that. So big old square root. Don't forget that. Let's take 16 and break that down. So what times what is 16? 4 times 4, right? Or what? 2 times 2 times 2 times 2. We'll just take it all the way down. That's 16. You can do that in your head, right? You don't have to do that little factor tree. Do you? So you can do that in your head. Let's do the z's. Now remember, we want to break them down into groups of 3, right? So how are we going to do that? I'll tell you what, let's do this. We want something to the 3rd power, right? So let's do it like this. Let's write it z cubed times what? Z squared. Remember you add the exponents? All right? And that way, oh, this is a cube, don't forget that. See, I've got a z cubed there, don't I? And then that will cancel out with that cube root. And that's z to the 5th. Let's do the same thing with the x. What am I going to do with the x's? Yeah, I could go x cubed times... Well, actually, let's do it like this. Let's break them down into... into squareds. So that'd be x squared, right? That's another x squared. That's x to the 4th, right? That's x to the 6th, and that's x to the 8th. All right? You could have done it. You could have gone x to the 6th, but you could have done it that way too. Do you want to do it that way? Okay, let's do it that way. You could do it. You could do it any way. Any of those ways, it'll still work. So you want to go x cubed, and x, that's 6, and then 2, right? Okay, that's good. That is probably a better way. I like that way better. What about the y's? Yeah, let's go y cubed and then y. Everybody see that? Okay, so here we go. It's cube root. So look at all those 2's right there. How am I going to group them? In the groups of 3, right? So what's the cube root of 2 times 2 times 2?
2.
It's just plain old 2, right? So I'm done with that. Now that, I shouldn't circle it because I'm getting rid of the things that I circled. That 2 is going to stay under the cube root. We'll deal with that in a second. Let's keep going. What about this z cubed? It's just going to be a z, right? Because the cube root of z cubed is just going to be a z. So that goes. I can't take the cube root of z squared, so that's going to stay inside of the cube root. What about these x's? What's the cube root of x cubed? It's x. So I'm done with that one. But I got another one, don't I? I got to take the cube root of this x cubed, which is x. Okay, it will be x squared in a second, but this one is x and this one is x. The x squared is inside the cube root. I can't simplify that, so I keep it there. What about the y's? Cube root of y cubed is y. All right, so I'm done with that one. So that's all outside the cube root. All right, because I simplified it. Everything that I marked off right there is outside the cube root now. But now, what's left inside the cube root? 2, and then z squared, and it doesn't matter what order, z squared, and what else? X squared, and one more, a y. There it is. Yeah, this x times x should go to x squared, right? So that x times x will go to x squared. And there it is. So once you learn the basic rules, it's just kind of repeating them over and over again, okay? Yeah, it's not too bad, is it? Just learn the rules, know how to take a cube root. If I have three of the same things inside a cube root, it comes out to just be the same exact thing, all right? I think that's good enough. There's a little bit more to this worksheet, but we'll do that on tomorrow. Is tomorrow? We don't have class tomorrow, do we? Monday then. All right, so here's what you're going to do. You're going to do, the worksheet is section 17A. You're not going to do all of it. You're just going to go through 1 through 8. So we've covered everything.
It doesn't look that bad.
We've covered everything on 1 through 8. This worksheet goes to 12, but we're not going to cover that right now. Probably could, but we'd just be cramming it in. So we'll just do that on Monday. Okay? That's it.